Good
Good
day,
day.
everyone.
I am Luisa Congzon.
I am Beatriz Vizcarra.
I am Ricardo C Mayrina,
I am Bernadette Borja.
and we are the reporters of Group 3. Today we are going to discuss about three topics. The first one is the ASTM C29 or C29M, or the standard test method for bulk density and voids in aggregate. The next one is ASTM C566, the standard test method for total evaporable moisture content of aggregate by drying. And the last is the ASTM C127, or the standard test method for specific gravity and absorption of coarse aggregate. So let's proceed.
Good day, I am Luisa Congzon, and we are the reporters of Group 3. I would be discussing the standard test method for bulk density and voids in aggregate or ASTM C29.
The scope of this test is to determine the bulk density, or also called unit weight, of aggregate in either loose or compacted condition, and voids between particles in fine, coarse, or mixed aggregates based on the same method. Applicable aggregates must not exceed 5 inches or 125 mm in nominal maximum size. English and SI unit systems are regarded separately as standard for appropriate specification with which this test method is used. Pero merong exemption when it comes to sieve sizes and nominal size. According sa specification E11, SI units ang standard. And hindi mo pwedeng paghaluin or pagsamahin ang dalawang magkaibang units kasi pwedeng hindi sila pareho ng value. Bulk density, or tinatawag ding unit weight of aggregate, is the mass of a unit volume of bulk aggregate material in which the volume includes the volume of the individual particles and the volume of the voids between the particles. Ang weight naman, ito ay ang mass of the body multiplied by the acceleration due to gravity, or 9.81 meter per second squared. Ang voids naman, ito naman yung spaces sa mga particles. Ito yung mga unoccupied spaces sa mga solid material. Merong iba't ibang significance ang procedure na ito. First is mixed design. Ang bulk density ay kailangan sa pagpili ng tamang proportion when it comes to concrete mixtures. Second ay ang relationship ng mass-volume conversion. Nakakatulong ito sa purchasing agreements. And lastly, nakocompute nito ang value ng voids. Importanteng malaman ng voids dahil nakakaapekto ito sa properties ng concrete. These are the apparatuses that are used in this test procedure. First is balance. Balance must be accurate within 0.1% of the test load at any point within the range of use. Graduated at least 0.1 pound or 0.05 kilogram. Second is a tamping rod. Straight steel rod, 5/8 inches or 16 millimeter in diameter and approximately 24 inches or 600 millimeter in length. Third is a shovel or scoop, used for filling the measure with aggregate. Calibration equipment. A piece of plate glass, preferably at least 1/4 inch thick and at least 1 inch larger than the diameter of the measure to be calibrated. A supply of water pump or chassis grease that can be placed on the rim of the container to prevent leakage. Measure. A cylindrical metal measure with handles. It is a watertight with top and bottom true and even. Shall have a height approximately equal to the diameter. Height must not be less than 80% nor more than 150% of the diameter. The capacity of the measure shall conform to the limits in Table 1. Sa Table 1, meron dito yung nominal maximum size ng aggregate at ang corresponding nitong capacity of measure in terms of cubic feet at saka liters. The thickness of metal in the measure shall be as described in table number 2. Sa table number 2 naman, kapag nakuha mo na yung capacity of measure from the table number 1, dito mo na makukuha yung thickness ng metal or ng metal ng measure na gagamitin mo. Yung thickness ng metal niya sa bottom at saka yung upper part ng wall, at the same time yung remainder or yung mga natitirang wall sa lower part. A 75 kg sample mass of 37.5 mm coarse aggregate is obtained from practice D75. Para ma-reduce ito to its sample size, you can use mechanical splitter or quartering in accordance with practice C702. The size of sample shall be approximately 125 to 200,000 of the quantity required to fill the measure and shall be handled in a manner to avoid segregation. For the procedure, first is the calibration of measure. Fill the measure with water at room temperature and cover with a piece of plate glass in such a way as to eliminate bubbles and excess water. Second is weigh the mass of the water using the balance. Third, measure the temperature of the water and determine its density from table number 3. If ever naman nawala yung temperature na nakuha mo dun sa table number 3, you can use the interpolation method. Calculate the volume V of the measure by dividing the mass of water by its density. Alternatively, calculate the factor for the measure by dividing the density of the water by the mass required to fill the measure. Measure shall be recalibrated at least once a year or whenever there is reason to question the accuracy of the calibration. For this video of calibration of measure, kunin muna natin ang mass ng measure and then punuin ang measure ng water, tsaka kunin ang mass nito. Once na nakuha na natin ang mass ng measure na may water, we can have the difference na. Once na makuha na natin ang difference, ito na ang value ng mass ng water. Ang nakuhang temperature sa experiment is 22 degrees Celsius. We need to interpolate para makuha ang density na 997.77 kg per cubic meter. And we can record this na as W. Para makuha naman ang volume, we need to divide the mass of water sa density na nakuha natin. Para naman sa pagpili kung anong procedure ang gagamitin, meron tayong dalawang condition, loose and compacted condition. Para sa loose condition, meron tayong shoveling procedure. Ginagamit lang yung shoveling procedure kapag ka-specified sa problem. Kapag naka-indicate doon na gamitin natin is shoveling procedure. Para naman sa compacted, meron tayong dalawang procedure. Ito yung rodding and jigging procedure. Kapag ka rodding procedure, ginagamit lang ito kapag ka yung coarse aggregate natin is 37.5 mm or less than pa dito. Pero kapag ka mas mataas naman siya sa 37.5 mm, doon na natin gagamitin ang jigging procedure. Sa jigging procedure, we need to fill the measure in 3 approximately equal layers. Sa bawat layers, dapat may taktak mo to ng 25 times ang magkabilang side. Bale, total of 50 times na pagtaktak siya or yung paghampas sa kanya. Total of 50 times. Para ka lang nag-aalis ng bubbles sa leche flan bago mo siya isalang sa steam. Itataktak mo muna siya. Parang ganun din siya. Pagkatapos mong magawa yon for the 3 layers, pwede mo na siyang i-weigh at kunin mo na yung record nito. Yung record nito, i-note mo siya as G. G na galing sa jigging procedure. For the rodding procedure, fill the measure 1/3 full and tsaka natin siya tusukin ng 25 times gamit ang rod. Hindi need na masyadong malakas ang pagpalo, yung tipong aabot na siya sa ilalim ng measure kapag ni-strike mo siya ng rod. Yung sakto lang. Sa two-third naman ng, two-third ng level ng aggregates. Ganun din, 25 times ulit. Pero this time, dapat mas malakas na yung force mo sa pag-strike ng rod dun sa aggregates. Same with the third layer, sa last layer niya. 25 times din and mas malakas na siya. Pagkatapos mong gawin to, yung pag-strike ng rod ng bolt ulit, tsaka mo na siya timbangin and i-record yung mass ng measure at aggregates. Record mo din to as G. I-note mo lang doon na ginamitan mo ng rodding procedure. Lastly ay para sa loose condition. Nag-iisa lang yung procedure natin for loose condition, which is the shoveling procedure. For the shoveling procedure naman, punuin natin ng coarse aggregates yung measure hanggang sa umapaw to. Tapos, i-flatten lang natin yung mga sumobra gamit ang shovel or pwede rin gamit yung kamay or any leveling na straighten edge na gamit para matanggal natin yung mga excess part. Pero dahan-dahan lang. Pagkatapos nito, pwede mo na rin siya ulit timbangin. I-measure mo na yung mass ng aggregates at saka ng measure. I-record mo to as G, tas inote mo na rin na ginamitan mo to ng shoveling procedure. So, para naman sa calculation, meron tayong tatlong given na formulas. So, first is the bulk density. Formula ng bulk density, which is M is equals to G minus T over V, or M is equals to G minus T multiplied by F. So, yung M, yun yung ating bulk density. Yung G naman, ito naman yung mass of the aggregate plus the measure. Ito yung nakuha natin from the 3 procedures, yung na-record natin na G. Tapos yung T naman, ito yung mass of the measure na kinuha natin sa first part, sa calibration of measure. Yung V, ito yung volume of the measure na nakuha rin natin sa first part ng procedure, yung calibration of measure. Tapos yung F naman, reciprocal lang siya ng V. Yung naunang explanation kanina na formula, ginagamit yon for computation of bulk density in an oven dry condition. This time, ang formula naman is for saturated surface dry condition. Yung saturated surface dry is, ito yung merong aggregate na tuyo yung outer part niya, pero yung inner particles niya saturated. So, ito yung formula. MSSD is equals to M multiplied by 1 plus A over 100. Yung MSSD, ito yung bulk density in saturated surface dry condition. At yung A naman, ito yung percentage of absorption. Makukuha tong percentage of absorption through test method C127 or test method C128, which will be discussed later. For the third formula naman, ito yung void content. So, for the formula of void content, percentage of void is equals to 100 multiplied by S times W minus M over S times W. So, yung M, yun yung nakuha natin kanina or makukuha natin through the first formula na bulk density. And yung S naman, ito yung bulk specific gravity na dry basis. Ito, makukuha natin to through the, yun din, test method ng C127 na madidiscuss later on. Next is yung W. Ito yung density of water na nakuha natin sa first part dun sa calibration of measure. Yung may equivalent na density of water yung makukuha nating temperature. So, for the sample problem, determine the bulk unit weight and voids in aggregate in either compacted or loose condition with the given data gathered from the experiment. So, ito yung mga nakuhang data mula sa experiment galing dun sa video, yung nakalagay nito sa table. So, for the loose condition, first step is calculate the bulk density with the mass of the aggregate plus the measure obtained from the experiment. So, ang nakuha nating G from shoveling procedure, kasi loose condition to, 24.64 kilograms. Ang gagamitin nating formula sa pagkuha ng bulk density is M is equals to G minus T over V. So, M M is equals to 24.64 kilograms minus yung T natin, yung mass ng measure, which is 4.52 kilogram, divided by the volume na nakuha, which is 0.013069 cubic meter. Ang makuha nating value ng bulk density from loose condition is 1,539.521 kilogram over cubic meter. Step 2 naman for the loose condition is to calculate the void content using the bulk density na nakuha natin mula sa step 1. So, percentage of voids is equals to 100 multiplied by S times W minus M divided by S times W. So, percentage of voids is equals to 100 times 2.5 multiplied by 997.77 kilogram over cubic meter minus 1,539.521 kilogram per cubic meter divided by 2.5 multiplied by 997.77 kilogram per cubic meter. Ang makuha nating value ng percentage of voids for loose condition is 39.49%. Para naman sa compacted condition, na ginamitan natin ng rodding procedure, step 1 is calculate the bulk density with the mass of the aggregate plus the measure obtained from the experiment. So, ang nakuha nating G from rodding procedure is 26.02 kilograms. Ang gagamitin nating formula, same lang din for the bulk density is G minus T over V, which is 26.02 kilogram minus 4.52 kilogram divided by the volume 0.013069 cubic meter. Ang makukuha nating value ng bulk density for compacted condition is 1,645.114 kilogram over cubic meter. Then step 2, calculate for the void content using the bulk density from step 1 ng compacted condition. Percentage of void, same lang din yung formula. So, 100 times 2.55 times 997.77 kilogram over cubic meter minus 1,645.114 kilogram over cubic meter divided by 2.55 times 997.77 kilogram over cubic meter. Ang makukuha nating value ng percentage of voids for compacted condition is 35.34%.
There are three commonly used test methods for performing moisture content tests of normal weight and lightweight aggregates: ASTM C566, ASTM C70, and yung AASTO T255. Pero yung pag-uusapan lang natin is yung ASTM C566 or yung Standard Test Method for Total Evaporable Moisture Content of Aggregate by Drying. It is applicable to both fine or coarse aggregate, and it is the most commonly used procedure. Let's start with the scope. This test method covers the determination of the percentage of evaporable moisture in a sample of aggregate by drying both surface moisture and moisture in the pores of the aggregate. Kasi, merong mga aggregate na nagko-contain ng water na chemically combined with the minerals in the aggregate. Such water is not evaporable and is not included in the percentage determined by this method. Second, the values stated in SI units are to be regarded as the standard. So, wala nang iba pang units of measurement na included dito. Bale, dito sa terminologies, papasadahan lang natin to para if ever na ma-encounter natin is, alam natin kung ano yung ibig sabihin. Absorption, the process by which a liquid is drawn into and tends to fill permeable pores in a porous solid body. Aggregate, used with a cementing medium to form hydraulic cement concrete or mortar. Moisture content, the mass of water which can be removed from the soil, usually by heating at 105 to 110 degrees Celsius, expressed as a percentage of the dry mass of the soil. Last, nominal maximum size of aggregate. Description of aggregate. the smallest sieve opening through which the entire amount of the aggregate is permitted to pass. Tumungo naman tayo sa significance ng ASTM C566. This method is significant for certain uses, lalo na doon sa pag-a-adjust or pagpapalit ng batch quantities na gagamitin natin para sa concrete materials. And dito, sa method na to or sa test na to, yung ma-measure natin na moisture ay accurate din siya. However, large coarse particles, particularly those larger than 50 millimeters, it will take longer time for moisture to move from the particle's interior to the surface. And kailangan mag-decide nung nagpa-perform ng test if yung rapid drying ba ay nagpro-provide ng sufficient accuracy. It is very important to determine the moisture content as it can establish relationship between how the soil behave and its properties. Next naman is yung apparatuses. Ito yung mga equipments na kinakailangan natin para ma-perform itong test method. First is the balance. Balance must be sensitive, readable, and accurate to 0.1% of the sample weight at any point within the range used for this test. Next is yung source of heat, ventilated oven capable of maintaining the temperature surrounding the sample at 110 plus minus 5 degrees Celsius. Pero, meron din namang iba pang suitable sources like yung electric or gas hot plate, electric heat lamps, or yung ventilated microwave oven. Pwede rin naman yung mga yon. Next is the sample container, not affected by heat and has enough space to hold sample without overflowing. So dito, meron din tayong precaution dito. Kapag gagamit ka ng microwave oven, kailangan yung container mo non-metallic. And kapag naman, sa mga large samples, an ordinary frying pan is suitable for use with the hot plate or any shallow flat bottom metal pan. Pwede na rin yun para sa heat lamps or oven. And lastly is the stirrer, a metal spoon or spatula of convenient size. Let's proceed with sampling. Sample in accordance with practice D75 or D75M except for the sample size. Yung D75, yun yung standard practice for sampling aggregates na diniscuss nung unang mga reporters. Dito papasok yung acceptance or rejection of material, and dito rin yung mga different ways kung paano ka kukuha ng sample. Obtain a sample of the aggregate that is representative of the moisture content of supply being measured and has a mass that does not less than the amount specified in Table 1. So dito sa baba, nandito yung Table 1, which is yun yung sample size for aggregate. Dito tayo magbe-base nung designated na minimum mass para dun sa size na aggregate na kukunin natin.
Once again, these steps come directly from the technician's handbook. When testing for moisture, we want to ensure that the sample that we obtain is representative of all of the aggregate. Be sure to obtain a sample at least as large as that required in ASTM T255, Table 1. Finally, make sure that you have a container large enough to hold this size sample. You now need to record the mass of the sample. Also, make sure that you record the weight of the container that the sample is in. A sample by heat. Avoid overheating, scorching, or any other alteration of the aggregate particles during the drying process. If a hot plate is used, stir the sample uniformly, ensuring that no sample is lost during the stirring process. Make successive readings to ensure that the sample has dried sufficiently. The sample is dried sufficiently when we have less than 0.1% loss in successive readings. We now want to allow the sample to cool and record the mass to the nearest 0.1 gram. We now want to record our data promptly. Again, the data that we'll need is the mass of the empty container as well as the mass of the now dry sample in the container.
So, for calculation, we have the formula for moisture content, which is yung P is equal to 100 times the quantity of W minus D over D, wherein P is equal to total evaporable moisture content of the sample in percent, W is the mass of the original sample in grams, and D is the mass of the dried sample in grams. So, the next part of the calculation is yung surface moisture content. It is equal to the difference between the total evaporable moisture content and the absorption, with all values based on the mass of a dry sample. So, yung absorption naman is makukuha natin siya in accordance with test method C127 or yung i-discuss mamaya. So, alam na natin yung formula kung paano ma-solve yung moisture content ng isang sample. So, itry natin itong sample problem para ma-apply natin yung natutunan natin kanina. And itong mga values na nandito, or ito yung mga data na nandito, is galing siya doon sa video na pinanood ko kanina sa inyo, doon sa experiment. A soil sample has a mass of 501.7 grams, and the mass of the container with the moist soil sample was found to be 702.8 grams. After drying out, the mass was reduced to 691.7 grams. Determine the moisture content of the sample. So, given yung mass of the container, which is 201 grams, container with moist soil sample is equal to 702.8 grams, and container with dried sample is equal to 691.7 grams. Since hindi given yung values ng W at D, solve natin sila ngayon. So, makuha natin yung W by subtracting the mass of the container to mass of the soil sample plus the container. So, yun yung formula natin para makuha natin yung W tsaka yung D. So, 702.8 minus 201.1 is equal to 501.7. Yun yung equal sa W. So, sa D naman is ganun din. Isusubtract natin yung mass ng container dun sa dried sample with container. So, yun yung 691.7 minus 201.1 grams. So, ang result niyan is 490.6. Dahil na-solve na natin yung values ng W tsaka D, pwede na natin gamitin yung formula ng moisture content. By supplying those values dun sa formula na meron tayo, makakakuha tayo ng 2.3%. And lastly, calculate the surface moisture content. Ito yung moisture na nakaka-apekto sa concrete mixture natin. So, let's say na yung absorption natin is 1.1%. So, ang formula natin is total evaporable moisture content minus the absorption. So, yung nakuha nating moisture content is 2.3. So, yung absorption natin is 1.1. Ima-minus na natin siya. So, makukuha natin yung 1.2 na moisture content.